Okay, I'm going to start. So I will be going through the questions where you make more mistakes. For example, like the MCQ or the first MCQ and the second MCQ seems to be okay. So I'm not going to spend time on that. Okay, it's quite straightforward. Like in this case, this boy wearing helmet, protect his head, right? So what kind of, property is it describing if it can protect this boy's head? Of course, okay, that kind of property must be related to strength, right? It's a very strong material. Very strong material can protect the boy's head. Okay, someone's in the waiting room. Give me 1 minute. I just let the person in first. Yeah. All right. Okay, next one. John carried out an experiment on 4 magnets. So quite easy, right? This will tell you, the strength of the magnet. So when you put the magnets into the pile of nails, the magnet that is the strongest will attract the most number of nails, right? So P must be the strongest and R is the weakest. So this is wrong. Oopsie. This is wrong. This is wrong. Okay, left with 2 only. Magnet Q weaker than R. Is that correct? Can Q be weaker than R? Not true. Okay. P is stronger than S. Yes. So this is the correct statement. Okay. So my 17 is your question 3. So diagram here shows experiment set up by Ramesh. He observed the shadow formed on the screen when the torch was shone. Let's see your answer. Let me see how many of you got this wrong. 3 of you actually got this wrong. Okay. Let me see what is your answer. B and B and C. Some of you chose B. Some of you chose C. Now, Yancy, would you like to let me know how come you chose B? Tell me. Yeah, Prita, you got it wrong also. Prita, you chose C, right?
Like the V was closest to the torch and thus like have the biggest shadow on the screen. So I thought like it will block out the rubber ball's shadow.
Right, I see. Actually, it's not possible because it's too small in that sense. Okay, if you have done experiments like this before, the distance, right, between the wooden block and the rubber ball, rubber ball, this is written wrongly, has to be very big. Okay, then it can form a very huge shadow. Can? Okay, Yancy, Prita said that she thought it's C because of the glass screen. Do you know what is the glass screen for? That is like our wall, it's like where the image is being formed, where the shadow is being formed. Okay, Prita? So it's the whole big screen that we are talking about, is where the image or the shadow is being formed. Clear? Can? So if you didn't understand, I hope you understand now. Okay, so answer is actually A. Okay, answer is actually A because, yeah, this is an opaque. Even though this is opaque, but it's too small. Both are opaque objects, but this one is too small. All right, and this is transparent. So all the light passes through, and therefore our only shadow is the rubber ball. Okay, that will be formed. All right, Ken. Next. Question 4, Shu Hui filled up identical beakers A and B with water and small stones. Okay, this one, 4 of you got it wrong. All right, so if you are going to look at it very carefully, even though this seems like reaching this level 200 ml, okay, and then the stones, the small stones also reaches a height here indicating 200 ml. But does it mean that the stones totally occupy all the space? No, right? What can you say? Yeah, the stones didn't take up the full shape at the bottom there. Sharia, okay, this is something you observe. Yeah, they leave small gaps. How many of you can see the small gaps? Are you able to see small gaps? Very good. So all these small gaps here, if I were to just indicate, not sure whether you can see my drawing, these are small gaps and these are spaces where the water can flow and take these spaces. You understand, right? Someone is there. I want to know who is this. I let the person enter first and then see who is the. I hope it's Keith. Okay, you have to rename yourself so that I can mark attendance. Right, back to this one. So when I pour the water in, what's going to happen? Okay, some of the water will fill up all these gaps, like you mentioned. All the gaps will be filled up first, and then the rest of the water will then fill up other parts of the beaker. So maybe, oh, cannot be so little, right? If it's 200, maybe around here. Okay, so it's going to fill up like this, right? You all got this, right? So it must be between 300 and 400 ml. Okay, so the height, the new water level will be somewhere here. We don't have an exact one because we do not know how much of these spaces there are. Clear? All these gaps. So do write down, copy down somewhere. Water will fill up the spaces between the stones first. Okay, so if I were to point to this and this, right, these are spaces, or you can call them the gaps. All right, let's go on. Okay, I hope you all copied already, copied down already. You can, of course, download the notes after this, after the lesson. Just need to go to the portal again. Yep, then you can download the notes. Okay, question 5. Peter actually put the same amount of cold water at 10 degrees. So same amount of cold water, all right? So amount is the same, temperature is the same, into the styrofoam cup and a plastic vase. Let me see question 5 first. Okay, question 5 people got it wrong. Okay, so when he touched them, his hands felt that the plastic vase was actually colder than the styrofoam cup. Which of the following explains why he felt that way? Okay, so talk about when you talk about this kind of question, which topic do you think is referring to? Which topic do you think is referring to? And what kind of concepts are being tested? What kind of concept being tested? Good. Yep, correct. Okay, the topic is definitely on heat. Yes. Yeah, so you are talking about the conductors, right? Yeah, the conductors. Okay, now, so we talk about conductors, we talk about what kind of conductors can we talk about? Conductors, you cannot just talk about this word conductor. Remember, there are two types of conductors, right? Yeah, Sharia talk about, good conductors of heat. And what's the other one? I want to see the terms that you are using. Okay, poor conductors. Do you use the term insulators? Do you use the term insulators? Glenn says yes. How many of you use the terms insulators of heat? Yancy is like, don't call me, right? Okay, let me call someone. Battle, do you think we use the term insulators for heat? Insulators of heat. Yeah, Don't worry. I mean, it's okay if you get it wrong. Yeah, we have conductors of heat, right? So the opposite of conductors, what do we say? Better now, a bit unsure. Okay, let me tell you the answer, okay? Don't use insulators of heat, okay? We only have poor conductors and good conductors. We don't say non-conductors also. They only slow down heat loss, heat gain, but they cannot prevent. You all know this, right? But electricity, we can use insulators because the non-conductors are insulators. We cannot say it conduct a little bit of electricity, right? No such thing, right? It's either they conduct electricity or they don't conduct electricity. Agree? Okay, but then for heat, we can't use the word insulator. Your teacher have told you this before. In PSLE also, we are very strict on that because the moment you say insulator, you are saying that it can't conduct at all. Okay, don't use that. Use poor conductor. Can we use bad conductors? Do we use bad conductors? Bad conductor of heat? Bad conductor of electricity? No, very good. You know your work. So write down somewhere now for those who are unsure. Okay, those who are unsure, write down for heat. We use good conductors of heat, poor conductors of heat. Okay, for electricity, we can use good conductors, poor conductors, but we can also use insulator. Clear? Okay, let's move on. So in this case, we are talking about heat transfer, right? So heat always transfer from a hotter place to a colder place. So which one is hotter? Is it the hand or is it that cold water? Of course, it's the hand, right? So you will expect heat to flow from this person's hand, Peter's hand, to the material. Because, okay, you have to understand, because there's cold water inside, is the same temperature. Okay, so that tells you how good or how poor that material is in terms of allowing heat transfer. What's the difference between conductor and insulator? Okay, Prita, if you're asking me about conductor and insulator, when we talk about conductor of electricity, that means electricity can flow. Insulator, electrical insulator, right? Okay, means that electricity cannot flow. I suddenly saw that my Google slides are, the Google sheet are moving. Okay. All okay, yeah. Right. Okay, if you all notice, I have two Google Sheets. One is 23rd August, one is a copy, right? You know why I have the copy? I have the copy of 23rd because I want to see for a very quick glance. I want to see the MCQ. Yashika, don't go to the one that is copy. Go to the 23rd of August, okay, to look at your answer. Go to the 23rd. Don't use the copy. Copy is just for me to look at the MCQ. Yeah, because I want to see how many correct, how many wrong. That's easier. Okay? Because I got distracted because it suddenly started moving. Gave me a shock also. Now, when you feel something is cold, you still remember about the carpet as well as a piece of aluminum foil, the difference when I touch aluminum foil, when I touch my ceramic mug, how come it feels cold? But when I touch the carpet, it doesn't feel cold. Still remember that one? You actually did that, I think, in P4. Yancy don't remember. Okay. Yancy, if you hold a glass, okay, empty glass, then you hold maybe a piece of cloth. Which one feels cold? The glass, right? Yeah. Why is it so? Because the glass is a better conductor of heat compared to the cloth. It is taking heat from your hand. Whereas that piece of cloth is a poor conductor. It doesn't take heat from your hand. That's why you don't feel that coldness. Understand? It's always about heat flow. Don't say that gain coldness or anything. No such thing. Right. So when you are answering this question, let me see who are the people who got this wrong. Okay. All right. Now I see it. Okay. So take note. the plastic vase actually conducted heat faster. So it's taking heat from your hand faster than the styrofoam cup.